Okay, today we're going to be talking about scalars and vectors. Vector is just a physical quantity that has both the magnitude, like how much, and a direction. An example of that would be like force, because a force would have how much and a direction. Like you're pushing down on your chair right now with a certain amount of magnitude, and it's a direction downwards. The same thing is true with acceleration. It has a magnitude, how much, and in what direction. Your book represents vectors by using boldface and arrows. That's usually the standard convention in textbooks. Okay. Arrows are used to represent vectors. The direction of the arrow gives you the direction of the vector. It's kind of obvious. By convention, the length of the vector is also proportional to the magnitude of the vector. For example, you have a 4-pound vector is represented by this line or arrow. But if you had 8 pounds, it was like double the amount, same direction, but it would be twice as long. On the other hand, a scalar only has magnitude. It doesn't tell you what direction. For example, the number of pages in your book would not give you any direction. And here's for an example. Let's say that you drove 2 kilometers away from your starting position. It really would give you no information whatsoever other than the fact that you're 2 kilometers away. You could be anywhere on the circumference 2 kilometers from your starting point. All right, let's talk about some vector operations, like how we add, subtract, and multiply them. Vectors can be added in 2 ways. Graphically, using a ruler and a protractor. The problem with this is that you have to be extremely exact, and it's very easy to make mistakes. But as far as understanding how they work, it's a good way to look at them. Or we can use geometry and trigonometry. All right, this should be obvious to you. Only like vectors can be added. For example, if you have 4 meters plus 3 meters equals 7 meters, that makes sense. 4 meters plus 6 meters per second equals, who the heck knows? It makes no sense at all. Can vectors be multiplied by scalars? Certainly. 4 meters, can you go twice as far as that? Yeah. 2. That would be simply 8 meters. All right, so how do we add and subtract vectors? All right, so vectors can be moved parallel to themselves. So let's look at this. You can't change the direction or the angle. If you do, then you're actually changing the vector. Because a vector has a specific angle that you're giving it, and if you just change it arbitrarily, then you've changed the vector. And they can be added in any order. This should make sense because you can, just like regular dish, you can add it in any order. For example, 3 meters plus 4 meters is 7 meters. 4 meters plus 3 meters is 7 meters. It doesn't really matter which order you do them in. All right, for example, let's take a simple situation where they're both facing the same way. We have a vector that's represented by 5-meter vector that's represented by this arrow, and a 3-meter vector that's represented by this arrow. If you add them what's called the head-to-tail method, what you're doing is you're finishing one and then starting the other. This total vector can be represented by this vector, the resultant of 8. That should be a pretty easy idea. All right, so let's look at some fun with vectors. All right, so we have this red vector and this blue vector. I took it out of the PowerPoint mode so I can move them around easy. And I just want to show you that if I add these 2 vectors together, if I finish with the red, and then at the head of the red, I add the tail of the blue, doink, it can be represented by the green vector. Okay? So you can either do this, or you can go straight across with the green vector. All right. But can you add them in any order? Certainly, as long as you keep them parallel. So instead of doing the red, then the blue, I could do the blue, then the red. And it will still give me the same resultant vector. One of the things I cannot do is I cannot add them tail to tail, because this is the resultant of adding them the correct way, And you can see it's not the result in this way. Okay? So that's adding them head to tail. Let me show you a quick little video of that as well.
Original orientation. We'll use these animated vector arrows to show a method of vector addition called head-to-tail addition. If we want to add vector B to vector A, we simply move B so that its tail is in the same position as the head of A, keeping it parallel to its original orientation at all times. The sum of the two vectors is found by drawing a third vector from the tail of A to the head of B. This is how the sum of the two vectors changes if vector B is rotated to different orientations. Since the two vectors are equal in magnitude, their sum can have a magnitude ranging from 0 to twice that of A and B.
All right, let's talk a little bit about subtraction. To subtract a vector, you just add its opposite. For example, 5 minus 3 can really be written algebraically as 5 plus negative 3 meters is equal to 2 meters. You just switch the direction of the arrow when you add it head to tail. Let me show you an example of that. If we have A plus B, it's equal to C. So you finish with A, you add B, and it would be the same thing as C. Now you could have obviously done B plus A as I just previously showed you. But if you did A equals C minus B, okay, you would have to take C, and instead of adding B onto the end of that, which would be up like this, right, you actually take the opposite of that, minus B, and add it together. So C minus B would be the same thing as saying C plus a negative B gives you A. Here's a couple more examples we can look at. Here you got A plus B equals AB. A plus a negative B, notice it's the same magnitude but the opposite direction, is equal to A minus B.